Hello, everyone. So as mentioned, I'm Jason Hancock. I'm an operations engineer with Graymeta. What we do, our application, we go out to large file stores. If something's in S3 or Azure, we'll go and we'll process all of the content in your bucket. We'll analyze the content. If it's video content, we might break it down frame by frame, do facial recognition, speech to text, things like that, extract the technical metadata from the documents, and then we'll stick those into our data store and make it browsable and searchable. So our workload that we throw at Nomad, it's a lot of small back-end batch jobs. Essentially, you get one job per file. We do a little bit of optimizations when we hit a lot of small files, so we'll batch several of them up together into one job. But you can think of it essentially as one job per file. And some jobs are small and fast. Others can take multiple hours to complete. You can imagine processing a 20 kilobyte JPEG might take a few seconds versus processing a 3-hour-long 4K resolution video of something like the presidential debates. That could take several hours to complete. So I want to tell a little story, sort of how we decided to pick Nomad. So in our original architecture, a user would come in either through our user interface or through the API and say, hey, I've got this storage sitting out here in S3 or Azure. And they would initiate what we call, they would tell our app to start walking that file system. The walker would then drop files into a traditional message queue, and so we'd queue up all these jobs. And then we'd have a back-end worker start popping jobs out of the queue and start processing them. It would then dump the results into a results queue, and then we had a little persistence process that was popping the results out of the results queue and sticking them into our database through our API. So to scale this original architecture, essentially we spun up multiple back-end workers across a fleet of servers. And it scaled horizontally pretty well, but there were some rough edges. Some customers have really, really big files that we had to process, and our scheduling algorithm was pretty dumb. At best, it was dump the job into a queue and hope for the best. So to counter our lack of intelligent bin packing, we essentially over-provisioned all of our nodes on disk. And 1 terabyte SSDs are expensive because we couldn't really control which node would end up with the job to process a large file. And our CFO wasn't very pleased with that, especially when they realized that we're provisioning 1 terabyte disks and we might be using 20 or 30 gigabytes of that at any one time, except for the case where we had to process 1 or 2 large files. So other problems at the time, we didn't really have a response for things like the image tragic bug. So our code, we use a lot of third-party executables to mine data from these files. So if someone were to harvest a file that had a malicious payload in it, we didn't really have a way to counter that. At the time, all of our processing nodes had a lot of sensitive information on it. They would connect directly to the client's storage to process, to be able to download the files. And so that was pretty bad. Some other problems we had were operability related. So we could easily add nodes to our cluster. We could just spin up more nodes and they would start reading from the queue and process files. But we didn't really have a way to tell a node to stop accepting new jobs while we let the existing jobs finish. And that'd be pretty easy to build in, except we had all these other problems as well. So we wanted a way that we didn't have to invent to be able to drain jobs from nodes. And the final problem, our biggest problem, really, was multi-tenancy. So our application, we run it as a SaaS most of the time, but we also can run on-prem. But for our SaaS model, our infrastructure, we were essentially deploying an entire copy of the infrastructure per client. So this meant that each client had a back-end processing cluster, and unless they were actively processing files, a lot of times they had servers sitting around idle. So this wasn't good. It also meant that I had to scale 30 separate clusters in response to load instead of scaling one up and down. So we wanted a way to share these back-end processing nodes across customers. So we started thinking about how we wanted to solve some of these warts or some of these problems. We settled on trying to do the processing inside a container because it would provide an extra layer of security. We also decided that the container was only going to get credentials to the absolute minimum amount of things that it needed. We were hoping that whatever solution we decided would try to solve a lot of the pain points of our current architecture. At the same time, we wanted to avoid writing our own scheduling and bin packing algorithms. We didn't want to try and invent those here. And we were hoping that whatever solution we settled on was going to be simple. So we started looking around at container orchestrators. And for our solution, it had to be really simple because we deploy we try to co-locate our compute wherever our customer's storage is. So if that's in Amazon, we'll deploy in Amazon. If it's in Azure, we'll deploy there. If it's on-prem on an NFS store, we'll deploy on-prem. So a lot of times, at least in the on-prem scenario, I might not be the person operating it. It'll be a customer operating it on our behalf. So it had to be simple enough for them to be able to operate. So it has to be easy to operate, has to have an easy-to-use API. It needs to be able to schedule based on multiple dimensions, CPU, memory, and for us, an important one was disk. And we were hoping it would be easy to integrate with some of our existing infrastructure components, like our centralized logging system and our metrics. So the only one that really fit the bill initially was Nomad. And Nomad solved a few of the problems immediately out of the box. So being that Nomad's written in Go and compiles down to a static binary, it's super easy to deploy. It's also very easy, we found, to operate. Out of the box, you're able to scale nodes up. And when you need to remove nodes from the cluster, it's really easy to flip on drain mode and start pulling them out of rotation. And it solves the bin packing problem for us. So now instead of having to over-deploy all of our nodes, we can only over-deploy one node, or over-provision one node. And Nomad will figure out when that large file is starting to get processed where to stick it in the cluster for us. On the easy-to-use API front, the Go client and also the Nomad CLI is really easy to use. So this is sort of a dummy block of code that would set up a job to launch a container, and it's really easy to actually launch. This is assuming you have Nomad running on localhost, without TLS or anything special there. Another benefit that we found to Nomad, being that it's written in Go, and we happen to be a Go shop as well, is that if the docs weren't clear, we had a full client implementation to go look at. We could go reverse engineer the Nomad CLI and borrow from it. So when we were considering integrating with other parts of our infrastructure, the one I mentioned earlier was our centralized logging system. We found it really easy. We didn't have to set up some complicated, Docker logging solution. For us, it ended up being just adding a wildcard path into our FileBeat configuration, and it picks up the standard out and standard error streams from all of our containers and ships those automatically over to our Elk stack. We also found it really nice that Nomad has telemetry built into it, and it was really easy to turn it on and point it at our StatSite server, so we could get all of our metrics into Graphite and kind of graph and see what's going on under the hood in Nomad. We haven't really had any problems with Nomad that would warrant us, analyzing all the metrics under the microscope, but it's nice to know that they're there if we needed to. So now that we had sort of a Nomad cluster up and running and we could launch jobs on it, we had to re-architect our application to make use of Nomad. So the first thing we decided early on was that the container themselves wouldn't directly access the storage. So we were gonna use our API to proxy access to the files. And the authentication that the containers were going to use to access the files through the API would be limited in scope. You'll also see that instead of the the backend worker reading directly from the files to process queue, that we have a scheduler process reading from it instead. And really what that scheduler does, all it does is it grabs a job out of the queue, and it's responsible for scheduling a job in Nomad. So it's really lightweight. We didn't have to put a whole lot of logic into it. We just fire the job at Nomad and wait for Nomad to handle running the actual job. And then once the job is running, the backend worker talks to the API, downloads the file, processes it, ships the results back. Instead of dropping the results back into a queue, this time we modified our API to accept the results directly from the backend worker, and those end up in our database. So when the container is actually accessing our API, we're using a narrowly scoped OAuth token, so that the only piece of information that the container can receive, or the only pieces of information that the container can actually have access to, are those that are relevant to the file that it's harvesting. So that means that it can only download the one specific file that we told it to, and it can only update the results in the database for that particular result, for that particular file. And now the other big problem that we had that Nomad solved for us was the multi-tenancy. So we needed a way to be able to run multiple customers' jobs on the same Nomad cluster. And to do that, we built sort of a generic container image, and then we inject all of our configuration in via environment variables that Nomad injects into the container runtime as it's running. So this includes URLs of API endpoints, the auth tokens, any specific configuration or keys that it would need to process the files. So a lot of our problems were solved by moving to this new architecture. I wouldn't call security solved. It's just more isolation, more layers. It solved our maintenance issues, so now we could scale up and down our clusters easier. I only had to manage a single cluster or a couple of clusters instead of 30 or 40 clusters. We can now deploy heterogeneous nodes. Each node was more realistically provisioned to the resources that it would actually use. And when the processes were running, we were seeing better utilization of those resources. So instead of a 1 terabyte disk and we're only using 20 or 30 gigs, now we're using 20 or 30 gigs of a 50 gig disk. So after we launched this and started running it in production, some of our customers came to us and said, well, we don't necessarily want to be on the hook for managing a Nomad cluster. Is there something you can do since we're hosting in ECS or in AWS? It'd be really nice if we could run it on an ECS cluster. And since we're a Go shop and Go has this concept of interfaces, we were basically able to abstract our scheduler backend so that we had a Nomad interface and an ECS interface. And that flexibility was really awesome for us. It means we can basically plug into any of the other container runtimes that we want or that our customers require. And it makes it really easy to swap one for the other based on the customer's needs. But for most cases, we're still deploying Nomad. One of the other kind of requirements that we didn't realize at the time when we were setting down to pick something was our development environment. We needed something simple and easy to operate, and something that we wouldn't really have to do any mocking or faking of in our dev environment. So we wanted to be able to run a full dev environment stack locally, something that resembled production as closely as possible. And for our dev environment, we use a monolithic Docker image that contains all of the backend components and pieces. Inside that container image, we're actually running the same version of Nomad and console as we do in production. The only real difference there is that instead of using the Docker driver, we're using the raw exec driver. And the only time that it's not the case that we're running a different version than what's in production would be when we're actually testing new versions of Nomad and console. We actually test them first in our local dev environments before we start testing on our test infrastructure. And And the reason we use the raw exec driver in our dev environment is it avoids us having to do something creative where we're running something like Docker and Docker. Our dev team is really, they're dispersed around the globe. So a lot of times if somebody's having problems at their 8 a.m., it's my midnight because there's folks all over the world. So it had to be simple enough that they could operate without my help or the help of my team because we're all based here, not here, but on the West Coast. Another reason to use raw exec for us was every time that we recompile our processing binary, we didn't want to have to rebundle that into a container image or do something creative where we mounted the binary into the container. And doing all of this allows our developers to iterate rapidly without faking anything. They consume the Nomad API the same way we do in production. The only difference is the Docker driver, or the raw exec driver. So, in summary, after re-architecting our platform to take advantage of Nomad and processing these files in containers, we discovered additional flexibility. We had better security. We didn't have to implement a scheduler or a bin packer at all. We're able to better utilize compute resources, reduce overall cost, reduce operational overhead, and it's sort of a win-win all around. We found it really easy to operate in production, and I really have no complaints about Nomad. It's been a great experience using it. So that's kind of our story of how we moved our backend batch processing into Nomad. And I know I probably went through that a bit quickly. I'm a bit nervous. I don't do much speaking. Great job. Thank you.
So we've got good time for questions if anyone has any questions for Jason, and I will go grab the mic.
For your workers, did you ever consider just spinning up a new instance depending on the file size you were working with instead of having these instances constantly running and taking up resources?
Yeah, we did consider sort of provisioning things on the fly, spinning up and down VMs or sort of adding capacity dynamically, building some sort of autoscaler. The big problem there was that the response time. As soon as the message is in the queue, our customers were demanding that they initially got some feedback that it had started processing. And we could sort of fake that while we spun up a node in the background. But really for our requirements, they wanted to have at least one node always up, always processing, so that they could at least see some activity. They were fine with us walking a large file system, and they understood that we might have to queue up 1,000 files and run them serially through the system, if they were only willing to provide like one compute node or something like that. But they wanted to have one sort of always up and always available. Oh, got a couple over here.
Hi, I was just curious, how do you deal with one customer like blowing out the rest of the nodes or just like overwhelming it with number of files, or is there a way to like segment down on customer ID and things?
There is. So we actually throttle the number of jobs that any one customer can schedule on the cluster at a given time. So we sort of throttle it. We say that there can be up to 100 or 200 pending jobs. And we have monitoring set up so that once those conditions get hit, we'll see it and we can react and scale the clusters up and down. Eventually, we're going to replace all that with automated processes as well.
Hey there, I'm just curious if you did anything to queue up draining or if you just use the drain function without anything special.
We're just using the drain function without anything special. Most of the time, since we're not, our scaling isn't being done in an automated fashion right now, it's all being done manually. We just kind of look at the cluster, pick the node that has the fewest number of jobs, put that in drain mode, and then terminate it once the jobs finish running.
So what advantages did giving your developers like a monolithic container give you over giving them like an image where you could more accurately represent what's happening in production?
So initially we started this by giving them using Vagrant. And unfortunately at the time it proved to be a little bit too unstable for the amount of stuff we were trying to run on a single instance. We're running things like Elasticsearch and Redis and NSQD and Go and all these things. And there was too much, I guess, delta from developer machine to developer machine. It was becoming sort of a maintenance nightmare. And also the time to provision was pretty long because they had to install all the packages from source. Or not from source, but install all the packages every time that came up. So with Docker, we can have our CI server spit out an image, and then they can all just pull down and consume that image. Yeah.
Any other questions? Nope. All right. A couple of quick announcements before we go to our very last break. For the evening social, for those of you who are going, and everyone should, I hope to see you there, there is not a coat check at the venue. So if you have a coat or a bag that you do not want to have hanging on you the whole evening, you may want to take this break to drop it off in your room. We will be back at 5:20 for our last talk of the day. And in the meantime, let's give another round of applause for Jason for a great talk.
Thank you.